Welcome everyone. This is lecture number 11 and this is the last lecture of unit 1, that is inside PC core components, and today we are going to study about system memory. Now, a memory refers to the physical devices used to store programs or data on temporary or permanent basis. Now there are two types of memory, primary memory and secondary memory. In this figure you can see primary memory is divided into these many parts. First is RAM, that is random access memory, then read-only memory, further and cache memory and registers. Further, RAM is divided into two parts, or you can say it is further classified into DRAM, SRAM, and ROM is further classified into PROM and EPROM, and EPROM is further classified into EEPROM and UVEPROM. Now you already know what is the full form of DRAM and SRAM. DRAM stands for dynamic RAM and SRAM stands for static RAM. So and static RAM uses bistable latching circuitry to store one bit each and hence is faster than its counterparts. Its high price prevents it from being widely used in everyday computing machines. Also, a random access memory is a volatile memory, means it can be erased. And now coming to DRAM, DRAM is widely used compared to SRAM, and DRAM is slower than SRAM. Important thing is in SRAM is it is using bistable latching circuitry. Bistable latching circuitry to store one bit in it. That's why it is very costly. ROM, it full form you already know, and here it is also written read-only memory. Read-only memory is again one more thing. Each and every memory is an integrated circuit having number of chips on it. Starting with ROM. The ROM stores some standard processing programs supplied by the manufacturers to operate personal computer. And you already know what is the standard processing programs. It is nothing but BIOS. Or you can say some part of BIOS that is stored in it in ROM. The ROM can only be read by the CPU, but it cannot be changed. The basic input-output program is stored in ROM that examines and initializes various equipment attached to the PC when the power switch is on. Is I already told during BIOS means it detects all the devices and peripheral equipments or peripheral devices attached to the PC during power on. So everything is stored in ROM, but the name is given BIOS. So just try to link with ROM. Means all these are permanent memory that is stored on ROM and it is given or it is installed during the manufacturing. It is a non-volatile memory, means it cannot be erased. Next is PROM, that is programmable read only memory. So PROM, once the programmers are written, it cannot be changed. Programs, not programmers, it is programs that are written that cannot be changed and remain intact even if power is switched off. Means whatever program is written, it is intact. If it will not change in any condition even though power is off. So prom is a type of memory, means it is ROM but it is programmable read-only memory. In that programs remains intact, means it is not change, it does not change it, even it does not changes its location. Next is EEPROM, that is erasable programmable read-only memory. EEPROM chip can be programmed time to time and again by erasing the information stored earlier in it. Since EEPROM is a ROM in that we can erase it and again program it again and again. Information stored in EEPROM exposing the chip for some time UV light and it erases chip. Means whenever EEPROM is under sunlight, not sunlight, sorry, ultraviolet light, then it erases its chip and then we can reprogram it again. And there are two types, EEPROM and UV-EEPROM. EEPROM is electrically erasable programmable memory, means, and UV-EEPROM is ultraviolet erasable programmable memory, means electrically EEPROM means we are erasing data with the help of electricity or you can say electrical signals, while in UV EEPROM you are erasing your ROM data with the help of UV light. Next is cache memory and registers. The CPU speed of is extremely high compared to the access time of main memory. Therefore, the performance of CPU decreases due to slow speed of main memory. Main memory is still slow because we are using dynamic RAM and dynamic RAM is used widely nowadays, and we cannot use static RAM, I already told, because it is very costly. So ultimately its speed is less. So to increase the speed there is a need of keeping some memory. That is nothing but it is a cache memory. So to decrease the mismatch in operating system speed, a small memory chip is attached between CPU and main memory. Means already speed is very less due to this RAM which is having less speed, but to decrease this gap, means to bring the speed of RAM to the speed of CPU, there is a need to attach some smaller chip, and a small chip is attached between CPU and main memory whose access time is very close to the processing speed of CPU. Means whatever the speed of CPU is there, the same speed will be same, or you can say approximately same speed of cache memory is there. Okay, means you can say if the speed of CPU is, you can say, for example, 16 megahertz, then it is near about 16 megahertz, the speed of cache memory. Okay, and it is used to store programs or data currently being executed or temporary data frequently used by the CPU. Means data it is used, means cache is used to access that data that is executed currently, or it is frequently used in a very small time, means in the nearer time it was used. So this kind of data is there in cache memory. Next is registers. The CPU processes data and instruction with high speed. There is also movement of data between various units of computer. It is necessary to transfer the processed data with high speed. So the computer uses a number of spatial memory units called registers. We already studied registers. There are general purpose register and others registers like stack pointer, program counter. All these are registers that a CPU is having, and for increasing the speed and performing all arithmetic and logical operations, these registers are used. Now this is the chart of secondary memory. you can see secondary storage device. There are two types of access of device. First is sequential and second one is direct access. Sequential is magnetic tape, means this works in the way like to access any data in magnetic tape. What one has to do, one has to look at the first data, that is it has to be started from first memory location. Means once if you want to reach to a location like 1000 address number 1000, then you have to access address from 1 to 999. After that you can access this magnetic tape. Second is direct access device. There are number of, or you can say, flavors of secondary storage. Magnetic disk, in this floppy disk and hard disk like zip disk, disk pack, Winchester disk are available. Optical disk like CD-ROM, CD read writer or DVD, and memory storage device are flash drive or memory card. Now here you can see the level of memories that we are using. Input sources can be keyboard, mouse, removable media, camera, scanner, remote source or any other source. These type of sources are giving some kind of input, and this is stored in and some at the very second level from lower side. You can see ROM and BIOS are there, then removable drives are there, and network or internet storage is there, and hard drive is there. Now coming to just some little higher, we can see physical RAM is available and virtual memory is available. Then little higher, cache, and then CPU registers. This pyramid shows that very high speed will be of CPU register, then slower will be the speed of cache memory, again slower will be the speed of RAM memory, again slower will be the speed of this kind of memory, and these are having very low speed. Speed means to access data from all these memory types of memory, or you can say sources, is increasing as we start from CPU register. CPU register is there in CPU, cache is near to CPU, RAM is also near to CPU, ROM and or BIOS is also near to CPU. All are near to CPU, and these are out of the CPU. So you can see CPU register will have very quickly the data can be accessed from CPU register, and likewise. Now we are going to see about memory size. What is memory size? Or you can say memory unit is the amount of data that can be stored in storage unit. This storage capacity is expressed in terms of bytes. There are 4 types of units and their description are given here. First is bit. You already know it is either 0 or 1. Only one bit is in binary. And second is nibble. It is a group of 4 bits. Again, then byte. It is a group of 8 bits. Word. It is a computer word. Like a byte is a group of fixed number of bits processed as a unit, which varies from computer to computer, but is fixed for each computer. Means it varies from, if you are using computer, or you can say there are number of computers and having different number of machines and different number of processors. So each and every computer will have different word number. But for particular computer, the word size is fixed, and the length of computer word is called word size or word length. It can be in microprocessor 8086 we have studied, the word was of 16 bit, that is of 2 bytes. So it depends on computer to computer what is the size of word. or you can say word length. Next is as the storage capacity increases, the unit is also increasing. You can see kilobytes, megabytes, gigabyte, terabyte, and petabyte, and their conversion are there. You just take a look on this. Now you can see the memory shapes. What is memory shapes, or you can say memory or types, and that is nothing but it is when we are talking about memory shapes or memory types, then obviously we are talking about RAM. So memories existed in the form of chips, that is called dual inline package, and the types of, or you can say modules which are existing are SIMM, DIP, SIPP, ZIP, DIMM, and RIMM. Next is starting with SIMM. SIMM is nothing but it is a single line memory module. Single line memory module contain one or several RAM chips. You can see there are 1, 2, 3, 4, 5, 6 RAM chips on this module. So this is known as SIMM. There can be 30 pins or 72 pins on this RAM, depending on the type of computer we are using. So 30 pin connector are 8-bit memory, while 72 pin connector are 32 bits memory, and you can see the size is given. Now SIMM can have two types of RAM on it. It can have DRAM or it can have SDRAM. DRAM is dynamic RAM chips and SDRAM is synchronous dynamic RAM chips. Second one is DIP, that is a dual inline package. It is an electronic component package with a rectangular housing and two parallel rows of electrical connecting pins. You can see this is DIP, and it is having two lines of pins. Likewise here, this is one line and this is the second line, and all pins are connected on some kind of breadboard. So this kind of structure is known as DIP. The package may be through hole mounted to a printed circuit board, that is, I already told, it can also be known as breadboard, or inserted into a socket. This is SIPP. This you can see there are also number of pins on SIPP, single line pin package, and previous was dual line pin package. In this, only one line of pins are available. It was short-lived variant of 30 pin SIMM random access memory, small printed circuit board upon which were mounted on a number of memory chips. It had 30 pins were there. 30 pin SIPP modules were pin compatible with 30 pin SIMM modules. Okay, now next is Zigline. It is also known as zigzag inline package or zip package. It was replacement for DIP. You can see there are these pins are in the form of zigzag. So it was encapsulated in a slab of plastic with 20 or 30 pins, and you can see the dimension. It is also having width, height, and length. Then next is DIMM. It is 64-bit memory, and memory chips are on both sides. You can see this is the front side and this is the back side. On both sides there are RAM chips. So 168 pins were there in all, and the dimension is larger than SIMM. Now you can see RIMM, that is Rambus Inline Memory Module. Packaging RDRAM, it was packaging RDRAM, means in this pocket there is RDRAM. 64-bit memory it was accessing, and 184 pins and two locating notches are there. You can see two locating notches.